You know what? That's a really good topic for the last day. So Danny's wondering why we keep on talking about Python 2 when there's Python 3 out. Python 3.0 was a failure. It's pretty much what it boils down to. Guido made the decision to break backwards compatibility with the Python 2x series in what was originally going to be Python 2.6, I think. So it's been a while since the decision was made. And the community outcry made everybody decide we're going to make a new version, major revision of Python 3 that will be backwards incompatible with Python 2. We'll continue parallel development of the Python 2 branch and the Python 3 branch. The main thing that they did is Unicode is a pain in the ass. If you've done any like web programming and had to deal with character sets, in brief, we've been pretending that strings are made up of ASCII characters, and each character takes up 1 byte, and there's a single non-dubious representation of each byte. And that's just simply not true in the real world. In the real world, textual data is binary data whose interpretation depends on how it's been encoded. Sad but true. And that fact is a real pain to work around in Python 2. So almost any substantial program that might undergo internationalization or be exposed to multiple character sets, like every web application ever written, has got some libraries to deal with Unicode issues, and it still bites you every now and then. So Python 3 fixed all that, and Unicode data is the basic string type. And that breaks every single other library that depends on Python 2. Big discontinuity. So nobody, absolutely nobody used Python 3, despite the fact that the engine is more performant than Python 2. And there's been parallel development, and they've released Python 2.6 and Python 2.7. We're getting close to the end of life of Python 2, and there's been enough progress in fixing third-party libraries to run on Python 3. But like, for instance, it was a major effort to get Django to run on Python 3, and I still don't know of anybody who's doing it in production. So we've had 2 versions of Python living side by side for a while, and the official word was it's fine to stick with Python 2 for production, and Python 3.0 is kind of a experiment to show you where the language is going to be, and hopefully in 5 years everybody's going to decide to migrate. And we're still in the are we going to migrate sort of phase right now. And I don't know anybody who's running Python 3 code on production machines. And that's not true. I don't know very many people that are running Python 3 code on production machines. If you are writing for your own machine and your library needs are adequately met, Python 3 is fine. And as a user of the language, semantically, not a ton will have changed unless what you're doing is heavily processing textual strings and Unicode. Aside from that, most of the concepts are the same, and there's very limited like syntactical changes to the language. There are a few, and there is a Python 2 to 3 tool that's written in Python that will convert your Python 2 syntax to Python 3 automatically for you, i.e. catching the few places where there have been changes in keywords and or syntax. And it's usually things like they changed how exceptions are caught, because you can catch multiple classes of exceptions, and you can catch the exception instance. And in Python 2, that's kind of an ambiguous list of comma-separated things. And in Python 3, they made that much more clearly a tuple and a instance. So they cleaned up some bits and pieces of the language, but it's not really a substantial change from a syntactical point of view. It's mostly a substantial change from a runtime and a string handling point of view. But we continue to teach Python 2. When you yourself have to use Python 3, there won't be a big learning curve, and it's mainly a matter of people getting their software to run on Python 3. The state of general web handling stuff in the Python standard lib is kind of messy. Partly because despite being considered the new in hotness, Python is a relatively old language, and it's been around since CGI was the way to do web applications. So exceedingly lame names, but there is URL lib in the standard library, which has a bunch of things having to do with reading URLs, parsing data you might get from URLs, and the slightly newer, slightly improved urllib2, which confusingly is not a complete re-implementation of urllib, but supplies some additional missing pieces. And about half the time I can't remember if what I want is in one or the other. And I compound my confusion by importing star from both of them. We'll just use a little bit of the basic functionality of urllib right now. And we're going to use a different data format. JSON is a commonly used format on the web. JSON stands for JavaScript Object Notation. And it'll look really familiar to you because it looks a lot like Python's dict notation with a few additional rules. JSON stands for JavaScript Object Notation. And valid JSON can be interpreted as valid JavaScript code, which is one of the reasons it's become a really popular data interchange format. If you're writing JavaScript, you can just grab some JSON and it's already parsed for you. It's kind of nice. It's also kind of dangerous when you're talking JavaScript. I put up some JSON. I left my file name .txt, and it's being sent with a text MIME type. So it's not really JSON, and I wouldn't be able to use it from JavaScript. But those are details that don't need to concern you if you're not a web monkey like me. But this is what JSON data looks like. I have opening square brackets, which would indicate a list, an opening brace, which would indicate a dictionary, and I have name, colon, value pairs, comma separated. Pretty much Python dict syntax, right? No problem understanding like what the Python representation of this would be. Almost identical. There are a few rules for JSON, like if I put a trailing comma here, that would break JSON for one major browser at least. urllib has a lot of stuff in it, but what I'm kind of interested in is this paragraph. And this is worth noting because it's basically Python philosophy. Python OOP engages in duck typing. And you'll hear that phrase thrown around. And duck typing means if it squawks like a duck and it walks like a duck, it is a duck. And what we're trying to convey by the humorous statement is Python doesn't concern itself a great deal with exactly what type of object you have. It's more interested in the behavior of the object. And some type systems are concerned with making sure that you have exactly the type that you think you have and perform complicated tasks by coercing types. Python is more forgiving. And it's not as concerned with exact types. And it's more concerned with the ability to do things. So urlopener.open will give you back a bunch of different objects, but all of them have a read line, read lines, file number, close, and info method, which means you can pretend that they're file objects. Hey, it walks like a duck, it quacks like a duck, it must be a duck, or at least we can use it as if it was a duck. None of them are actually file objects for the most part, and we'll see that real quick now. I'm going to use urlopen, and I'm just going to pass it the URL I put in my browser up there. FP is a add info URL whose file pointer is actually a socket object. So this is reading from a network. But to get the data out of it, I could do read line. I'm not really interested in lines. I just want the whole thing. So I'm just going to say fp.read and fp.close. And data is, new lines included, the JSON that was up there at SimeonFranklin.com. So I just used a socket object, made an HTTP connection to a particular port, but all the details of that are hidden from me, and basically I got to pretend like I was reading from a local file, which is nice. And now I have a string that is JSON, like this is a string. I can't yet say, give me the first row. That just gives me the first character. So to parse this string, I can use the built-in JSON module. And JSON only defines a few functions. You can change how the decoder works and do a lot of customization. But mostly you don't have to do that. And mostly you're going to do load, which takes a file, or load s, which takes a string, and dump, which takes a file, and dump s, which takes a string. Wrong direction. I'm loading some JSON data, and what I'll get back is native Python types. So I'm going to reassign my data, and now data is a list of length 2. Data 0 is a dict that has keys and values. You'll notice the presence of the leading U, which indicates that these are Unicode strings, but you pretty much shouldn't worry about that right now. And if I were importing address book data, it would be pretty obvious how to do it from here. I can loop over the rows that I've got and read the labels that I've got. If you would like to add to your address book the ability to read a remote URL and import the JSON data that you find there, you know enough to do it now. The URL is here. And url_lib.url open gives you a file-like object. It's worth noting one of the other built-in file-like objects is a string IO class. And that is in, is it in the file module? It might be in the file module. It is in the string IO module. Sorry. The string IO module defines a string variable that's actually tied to a buffer, and it has read, write lines, write lines, basically emulates the file object. And what that means is if you write functions that accept files, file pointers, as arguments, you can test them by converting a string to a string IO and passing it the known data that you have without having to have data files separately laying around. So that's kind of useful. It's also sometimes used to get around the string concatenation issues. So if what you're composing is a really, really large string, like say you're manipulating documents, you might use string IO and write to it. And as opposed to the native Python string class, string IO works by pre-allocating a really big buffer and then jumping up in big chunks when it needs to. So appending to it doesn't cause any memory changes until you hit the buffer size, and then it doesn't cause any memory changes for a long time after that again. So it's more performant.
I think I missed the explanation of what that U is.
So the fact that there's a U before the string is Python's representation telling you that this is a Unicode string. But for the purposes of this class, Unicode strings and Ascii strings are all exactly the same thing.
So if you print it, it'll print.
If you print it, it'll print. You're just seeing the U because it's by default doing the repr, the programmer's representation, and you might want to know whether it was a Unicode string or an Ascii string or whatnot. So really briefly, strings that we're used to are in Ascii, which is an encoding system of 255 numbers that correspond to letters. And it reads text by saying, this is the number 31, therefore it has to be A. I forget what the Ascii numbers are nowadays. It turns out 255 characters is not enough to represent every character in the world's languages. So there's a whole variety of, originally the idea was we come up with a whole variety of different encodings. And you might have seen, like in your browser, you can select from encodings like kanji. Eventually, we sort of standardized and said, well, what if we made strings instead of 1 byte, we made them 2 bytes? And then what if we said that you had to define the name of the encoding that the following string data was in, and then strings would be portable? And that whole effort is called Unicode, and is a particular encoding called UTF-8. And it turns out that a couple of bytes isn't enough. That's actually UTF-16. A couple of bytes isn't enough, so there's UTF-32. And it still turns out that that's not enough, so there's tons of Unicode encodings. And basically what that means is when you have a Unicode string, you don't know what an individual byte represents as a character unless you know how it was encoded. Because different encodings specify different numbers mapping to different characters.
So from the programming perspective,
from the programming perspective, we're going to pretend that we always have Ascii strings.
Okay.
Python is capable of saying, here is an encoding, the name of an encoding, as long as the encoding is installed in your system. Here's a string to read using the encoding and giving you back the proper characters.
Okay.
It's also capable of just having binary style strings, whereby you don't make any assumptions about the type. And I've done some programming that way, and you'll see, if you ever see programs that have /x and then some hexadecimal number, that's directly embedding Unicode characters, and frequently you'll pass those around as binary strings to keep those from being interpreted in any way, shape, or form, but it's a big, gnarly mess. In almost every, most of the cases, you're not going to have to worry about it, especially since we're doing like command line programming against ASCII text.
Right. Okay.
Get to the web, and it's a different story.
Yeah, just one more thing to worry about.
Exactly.
So the JSON module
just parses JSON or creates JSON. So if I have a list that contains a list and a string, notice what I get back is a string. There's quotes on the end. And inside that string is the JSON representation, which is pretty close to the Python representation, although double quotes are mandatory instead of single quotes. And I will say JavaScript as a language seems to be rapidly converging towards Python. So not in your browser so much, but newer versions, because your browser limits the version of JavaScript you can run, but newer versions of JavaScript have stolen from Python things like list comprehensions, for example. And the object literal syntax here is stolen from Python as well. So I'll give you that URL there just in case you want it, because I'm putting the survey URL back up. So one more module to discuss, and this might actually help you, especially early on in your explorations of Python. One thought that occurred to me, I think I should introduce Unittest early on in the class and hand wave over the object-oriented part of it, because Unittest would actually be kind of useful for some of the assignments. If you're lost in your classmate's program, it's kind of hard to debug it sometimes. Like, OK, to get to the part that I want to mess with, I have to run it, load all the data from CSV, add another name, then filter by role, and it like takes a bunch of keystrokes to get where it is exactly that you're going. Kind of confusing sometimes. There's a style of development called test-driven development. And the basic idea is I already know what I want to do. And I'm going to write a test that says when I call this function, I should get back, when I call this function with this data, I should get back this result. And I'll define the function, but it won't do anything. And I'll run my tests, and my tests fail. And now I'll fix the function until it meets my tests. And as long as it meets my tests, then that function is going to be usable by the rest of my program. And it means to debug your filter by role function, for instance, instead of like loading data and stepping through your program interactively till you get to the spot where you can test your filter by role function. You could write a test for your filter by role function. And your test might have enough output that on successive iterations, you don't even have to step into it with PDB. You can just see, oh, right, I forgot to strip the trailing new line. Oh, right, I've got tuples instead of lists, and work through until your function passes. We've talked about doc tests as far as testing goes. And doc tests are kind of more like once you've got things working, you add some tests that guarantee that things stay working while they change. And also the tests are kind of useful as documentation, and they should probably be kind of minimal. There's another testing library that is much more frequently used for extensive testing. It's the Unittest library. Unittest is a straight port of JUnit, so if you've ever written JUnit tests, unit tests should look totally familiar. And basically the way unit testing works is probably a separate file called tests.py or something like that. I'm going to write classes. The classes inherit from unittest.testCase. The classes may define a method called setup that does whatever initialization I need to do that's common to all of the tests that I want to run for this class. And then I will write functions whose name starts with the word test. And then they're named whatever you want to name them. And each function should test some sort of discrete piece of functionality. And at the bottom, I'm doing the if name equals main thing and unittest.main. Unittest.main is the unit test supplied main function, and it loads all the classes in the module. If they inherit from unit test, it parses all of their functions, it runs the setup if it exists, and one at a time runs the test methods if they exist, and reports about it all. So let's run our tests. I defined one test, and actually, just to look really quickly, I did setup. I imported my classmates.9 file as C9. My classmates.9 file is reading from a CSV, so it starts out with a data structure called classmates that's blank. There it is. It's a module level constant. So I'm putting some data in it as part of my setup. And then my test is calling the save to file function that's in my classmates9 file. It's got a textual string. It's reading the CSV file. And it's using a special method. And I said self.fail unless equal. And I don't define fail unless equal. Unittest.testCase, which I'm inheriting from, defines a ton of fail methods which do checks for you. So fail unless equal obviously checks to see that the two things that you pass it are equal, and if they're not, it's a test failure, and if they are, it's a test success. And there's the more flexible fail if, and various other fail functions. And when I run this, it says fail. Test writing CSV is the name of the test that failed. It gives me the traceback. And I said fail unless equal text and ftext. And assertion error, John Smith student, Simeon Franklin instructor is not equal to Simeon Franklin instructor, John Smith student. Why not? Well, two things. One, my CSV writing is putting a blank new line at the end of every line. So I need that. And then, yeah, the other issue is the order's reversed. And the order's reversed because I am writing a dictionary. And dictionaries have no order. And I could right now switch the order of my lines, and it might pass this time. Which it did. Ran one test in 0 seconds. OK. And it put 1 dot because it ran one test. But this is a really fragile test because dictionaries don't have order, and I'm relying on some sort of implicit order that might vary in the future depending on what machine this was run on. So one really nice thing that tests do for you is give you different entry points into your functions, different ways of testing your function in isolation from the rest of your program, which is usually easier than testing it in conjunction with running the rest of your program. The really nice thing tests do for you is make you think about how you wrote your program in the first place. And changing your program to be more testable usually means changing your program to be more readable as well, or more sane. For instance, this C9 save to file thing, I have hard-coded the file that I'm writing to. So when I run my test, I overwrite the data file from my program. It's really dumb to have a hard-coded file, although I'm expecting to have a hard-coded file. So I'll make a change to my program. OK, the change I made was I gave my function an optional argument called fname that has a default value of data.csv. Because it has a default value, that fname does not have to be passed. And my program, which previously expected the save to file not to accept any parameters, can still call it without any parameters, and everything will work as before. But my test can now supply its own file name to write to, and I won't be clobbering my main file name. And I would probably use the OS temp names directory to get a guaranteed unique temporary name, or os.tempnames module. And then the reason my test is failing is because dictionaries don't have an order. And the reason my test is a bad one is because dictionaries don't have an order, and my write to a CSV writes in whatever order the dictionary happens to give it to me, which I can't count on to be reliable from time to time.
Okay.
And since the fragility of this test is bugging me, this tells me that probably it would be a good idea to go back to my classmates program and the save to file. Instead of doing for key in classmates, I should probably do for key in classmates dot keys sorted, which guarantees that I'll write it in the same consistent order every time. And I don't really care what that order is, because I'm not that concerned about the order in the CSV file, but at least it will be in exactly the same order every time. So my test helps me debug my program. It guarantees that my program continues to work, because I can rerun my test after I've made some change. And if my tests still pass, I'm probably good. And it also forces me to write my program in a manner that can be tested. For example, how could I test the getRecord function? GetRecord function probably doesn't need to be tested. It's pretty much just for input. The queryRecord function, I'd like to be able to test the queryRecord function, because I'm going to change the implementation from looking at a dict to searching through rows. And I'd write a test beforehand to make sure the test worked. And then I'd change the implementation, and I'd run the test again. And the test should still work. But I can't really test the queryRecord function because it has raw input in it. So it would probably be a good idea to pass an fname to queryRecord and get the input separately. Which meant that I pulled one line out and made it a new function. This text, this line of code, probably doesn't need to be tested. It's probably going to work. I'm probably not going to change it. But this queryRecord function, I'm going to totally change how this thing works. And I'd like to be able to write a test for it. And now I could, because I pass it a name, and it's going to look up the name. Let's write a test for that really quickly. might change one other thing about it. If fname in classmates, I print record, else sorry not found. Yeah, that kind of sucks. I've got print statements in it. That's kind of hard to test as well. Again, not impossible, but kind of hard. Let's just return classmates fname. Function's default value is return. So I'm going to solicit the first name, call my function that I'm going to be testing, and get a row back. If I got a row, I'm going to print a row. With print record. Else I'm going to print sorry not found. So I've moved all the input and output to query record input. But the actual logic of query record, which again I'm going to change big time, is now shorter and testable. And I'm going to say c9 dot query record. And it's based on the first name. So I have John in my sample data. And a nice simple usage at the beginning. What I'm kind of looking for, not the description, looking for the methods. There we are. There's assert methods. And I love some of these. Assert not almost equals. There we go. Assert true. Let's see if this does what I think it does. I'm an idiot. Two functions with the same name, so of course it's only running one. OK, now I did test query record, which worked, and test writing to CSV. Oh, hey, when I changed it to be in the right order, it failed. And if you remember, I changed it so it'd be in order of the first names. So my previously failing test or my previously passing test failed again because I didn't run my test after I made a change. But there we go. Two tests ran. They both passed. So I must have gotten a record back when I queried. And now that means I can go ahead and change the implementation of my query record function, change my data structure to be just a list, search through my list, return a row or a row of rows, and my test query record will make sure that at least I'm getting something back. Plus, it just makes it easier to test functions in isolation, I think, than against your whole program. I'm not a big test-driven fanatic in that I rarely, as the first step of writing my program, write a bunch of tests, which some people do. But I do find it helpful. And sometimes when I'm confused or conflicted about exactly what it is that I'm trying to do, writing the tests forced me to say, OK, what is it that I'm really trying to do in the end here? What's my final result going to be? What's the format going to be? And making those decisions in my test then clarifies my work of writing the rest of my code. So Unittest is useful both as a way to test your code, interactively write it, and also as a way to stop and think about it in a different way rather than bang your head repeatedly against the same wall forever. If you're frustrated with the progress in writing code, stop and write some tests. really simple tests that fail and make sure that they pass. And they can be really simple tests, but make sure they pass. And you're just thinking about the problem domain in a different way, and that's frequently useful. At least I find it frequently useful.